mathematics of chemistry, mole, particle, molar conversions. Specifically in this tutorial, we're going to look at what is a mole-particle conversion, converting moles to particles example, and finally converting particles to moles example. Molar conversions. Specifically in this tutorial, we're going to look at mole-particle conversions, where a particle can be an ion, a compound, a molecule, or atoms. Chemistry conversions are the same type of conversions as in dimensional analysis, which at this point you should be quite familiar with. The conversion factor that we're going to use is the idea that 6.02 times 10 to the 23rd particles is equal to 1 mole of particles, or 1 mole of particles is equal to 6.02 times 10 to the 23rd particles. How many aluminum atoms are in 0.371 moles of aluminum? So our given is 0.31 moles. What we want is the number of aluminum atoms. Our conversion factor that we're going to use is 1 mole is equal to 6.02 times 10 to the 23rd atoms. So the way that we're going to set this up is first by writing our given. So the given is written here, 0.371 moles of aluminum. We're going to put our multiplication sign in our line. We're starting with moles, therefore 1 mole will go on the bottom. We want atoms, and when you hear the terms atoms, ions, molecules, formula units, you know that you will always include Avogadro's number, which is why we're going to have Avogadro's number on the top here, 6.02 times 10 to the 23rd atoms of aluminum. So moles will cancel moles, and we're going to multiply together 0.371 times 6.02 times 10 to the 23rd. And when we do, our answer is going to be 2.23 times 10 to the 23rd atoms of aluminum. And we want to make sure that we do that to the correct number of significant figures. So if we start with 0.371 moles, and that's to 3 significant figures, our answer should be in 3 significant figures, which is why it is 2.23 times 10 to the 23rd. Now I'd like you to stop and try the next one on your own using the format that you saw above. Welcome back. Let's see how you did. How many molecules of glucose are in 3.5 moles? So the first thing that you should have done is written out the number of moles that you started with. 3.5 moles of glucose. A multiplication sign and a line. If we start with moles, then we will have 1 mole on the bottom of glucose. And what we want here are molecules. So again, as soon as you hear molecules, atoms, ions, or formula units, you know that you're going to use Avogadro's number. So on the top, I'm going to put 6.02 times 10 to the 23rd molecules of glucose, and then I'm going to put my equal sign. Then before I do my calculations, I need to know that I have done it correctly. So moles cancel moles. I multiply 3.5 times 6.02 times 10 to the 23rd, and the answer that I should get is 2.1 times 10 to the 24th molecules of glucose. The final thing that I want to do is look at the problem and make sure it makes sense. I have 3.5 moles. Moles represent 6.02 times 10 to the 23rd. So my number at the end should be a huge number because I have 3.5 moles. And if I look at my answer, 2.1 times 10 to the 24th molecules of glucose, that's a huge number. So in general, my answer makes sense. Let's go in the opposite direction now. How many moles are in 1.22 times 10 to the 20 atoms of silicon? So my given is 1.22 times 10 to the 20 atoms of silicon, and I want moles of silicon. My conversion factor, again, will be 1 mole is equal to 6.02 times 10 to the 23rd atoms. So the first thing that I'm going to do is write down my given. 1.22 times 10 to the 20 atoms of Si. put a multiplication sign in a line. If my given is in atoms, I'm going to put atoms on the bottom. I want moles, so 1 mole of Si on the top. And then I'm going to put 6.02 times 10 to the 23rd on the bottom. Atoms cancel atoms. I'm left with moles, which is what I want. So what I'm going to do here is I'm going to multiply together 1.22 times 10 to the 20th times 1 divided by 6.02 times 10 to the 23rd. And as a result, I should get 2.03 times 10 to the negative 4 moles of silicon. And again, I need to look at my answer and make sure that it makes sense. So I start out with 1.2 times 10 to the 20. That's less than 1 mole because we know that 1 mole is 6.02 times 10 to the 23rd. So I should get a number that is less than 1, and I have that because I look at my exponent, it's to the negative 4th. So 2.03 times 10 to the negative 4th moles makes sense. Now what I'd like you to do is stop, try the last one, and see how you do. Welcome back. Let's see how you did. How many moles are present in 5.00 times 10 to the 23rd atoms of chromium? So the first thing that I'm going to do is write out my given. That's 5.00 times 10 to the 23rd atoms of Cr. I'm going to do a multiplication sign in a line. I have atoms on the bottom. I want moles, so 1 mole of Cr on the top. I know that there's 6.02 times 10 to the 23rd atoms in 1 mole of anything. The next thing I want to do is make sure that my units cancel. So atoms of chromium cancels atoms of chromium. I'm left with moles of chromium. So now what I'm going to do is 5.00 times 10 to the 23rd times 1 divided by 6.02 times 10 to the 23rd. And as a result, I should get 0.831 moles of chromium. And again, this makes sense. I start out with 5 times 10 to the 23rd moles. I know that 1 mole is 6.02 times 10 to the 23rd, so it's slightly smaller than a mole of atoms. So 0.831 moles of chromium makes sense. So what did you learn? We talked about what is a mole particle conversion. We talked about converting moles to particles, and then we looked at an example where we converted particles to moles. Need more help? Feel free to contact me. Have a great day.